if you have over there, maybe it's quicker than trying to fix it here.
Yes, sure. Let me just open up the tab. Diviners. And okay. Spotlight. Share screen. There we go. Hopefully, fingers crossed, you can see that.
That looks good. Looks good. Thank you, Christopher. Shall I start then?
Yes, please.
All right. So I'm Frederick van Amstel. I'm presenting on behalf of the first author, Elias Hermut Neto. Besides being a co-author of this paper, I'm also co-author of the next paper by Tanya, and I was also a studio instructor in this environment that they both have conducted their studies. I come from an industrial design and interaction design background, so I'm a bit looking for interdisciplinary collaboration over here. And what we studied in this particular paper written by Elias and us is an oral history qualitative study on the trajectories and historical paths that this type of student went through in their lives. This is we call them diviners because they have both a background in design and development, and therefore we are using this funny but also very revealing name for people that does not fit into a single box. They really trying to push the boundaries wherever they go through. And what you can see in this slide is part of the qualitative analysis. On the left side, we are compiling and reflecting on what we have heard from all the interviews, the oral history interviews, using legacy display. Then later on, we are using Atlas TI in a much more rigorous way, grounded theory-inspired method, coding and finding the common patterns across these different trajectories. We interviewed around 16 diviner students, but the number of students not as important as the depth of this qualitative analysis. So in a nutshell, that's it. We are comparing and these different trajectories and finding some patterns and proposing that in software engineering education, be more mindful about transdisciplinarity, which is different from most of the conversations on multidisciplinarity, interdisciplinarity, and also other discussions on technical skills. So this is all about bridging the gap between disciplines and also reaching new knowledge that is not yet in any of these disciplines. So that's it. Thank you.
Super. Thank you very much. And can I just check, if I switch to my Word document, that's not going to be sharing that as well, is it? You still seeing the slide?
No, I still see the slide, for me at least.
Super. Excellent. Excellent. Right. Thank you very much. So I'm going to open it up to questions. The official discussant is Tanya, but I'm certainly open to anybody who wants to ask any questions.
Okay.
Perhaps we don't need the slides any longer, right, Christopher?
Yes. Yeah. Thank you.
Welcome.
Right. I would like to ask to Freddie, why did you choose the oral history as a method
that's a good question, because it's not a very common method to use in qualitative research done in software engineering, much less in computer science education, because oral history was a choice. Since we first started studying the diviners, we noticed that it was not just a matter of their skills or their practice in a specific moment. They really brought some different and variety in their backgrounds. So we had to look at the history of these people, and we searched for a qualitative method that could help us to trace that history. And we also found out that oral history was good for people that has been left from the official history, people that have been forgotten or has not been represented well by the histories of a particular discipline. And that was the case for them because they did not see themselves completely fit either in design, either in computer science. So that was the choice.
I think. I don't know if someone has another question or I can do another one.
Please, please.
In this Lego slide, you mentioned that you are looking for some patterns. And did you find it?
Yes, I think that's the main findings of these research is that these people, they have some commonalities. Although they have went through many different experiences in their lives, it seems like they have a common pattern. We only have a small set of people in our study because we really focus on that. However, we could still find some commonalities. For example, they have a part in their lives, especially during childhood, when they really try to understand how their electronic toys work. All of them basically said this. And that's an interesting pattern that might be related to their professional choices later on. So this curiosity never ceases in their lives, but they get complemented by other patterns. For example, being arguing, questioning everything that comes from disciplines, not accepting knowledge as something that is made up and closed and fixed.
Super. I'm going to jump in with a question.
Yes, please.
You identify traits of a diviner. So you've got curiosity. They are self-taught. They are creative. They are a communicator. So I'm interested in perhaps some of the trade-offs or perhaps the negative sides, if you've seen any, of a diviner in a studio. So what are the negative aspects of studio education on diviners?
Well, we began the whole investigation because of the drawbacks. We had this role, the diviner role, and this was never tried before in the software studio. And the first cohort had trouble in integrating these students because they did not fit within the expected roles in the software development team. This is not addressed in this paper, but I can share. And I think Tanya might also jump in because she also experienced and observed some of these situations that once the diviner does not know what he has to do and he knows what he's supposed to do according to the expectations, but in fact he has to somehow question and challenge that. That's what is expected from their role too, especially from the studio instructors. So that generated some conflicts among the students. Sometimes the diviners would join all of them together and do some kind of a therapy group work because they were feeling too much pressure, either from both sides. But we explained them, this is actually your role to be precisely in the boundaries, and where the boundaries are, there will be always some conflicts that we have to work out, and that's what you have to mediate and somehow help. But it was more pressure than we actually expected the students to experience.
Okay. Did you balance this difficulty in any of the grading and the assessments and things like this?
Well, this was more related to the kind of coaching that studio instructors would provide to them. Diviners required more coaching than developers and designers because since the knowledge could not be on how they could perform, was not achievable through other means that they could in a self-taught way learn, the studio instructors had to coach them extensively and also provide some psychological and emotional support because it was really demanding for them. And I have to say that in the next cohort, which is not included in any of these two studies, it's very recent, we decided that we wouldn't have diviners as a separate role. Instead, we would train all the students to be a diviner so we wouldn't have some kind of prejudice against diviners. So if you come from a design background, you would have to become a diviner. If you come from a development background, you would have to become a designer. So this was the way we found to alleviate the pressure on the specific students. somehow their
Super.
designer identity became a kind of a stigma in some way. Once other students said, well, who are these guys? Do they think that they are much better than us because they can do both things?
Sure, sure. Did you find that there might have been some tension between perceiving designers as generalists as opposed to the specialists, or is this kind of what you were just saying?
Yes, I don't think generalist was a problem. It's more what was more like they have to develop different skills that their peers would not always understand where they come from, if they are really skills. Because sometimes communication is not considered a skill in software engineering, especially for developers. They see this person who's talkative, and they say that person is talkative. It's a personal skill. It's not a technical skill that you have to develop. Because communication is also a technical skill. There are even communication faculties, and they study this matter, and it's not easy to develop this skill. And so this scared some people that didn't have a full range of skills, because they said, well, maybe they are trying to fool us. they are telling bullshit. So we would never know in these interactions what was happening. But we tried with this change to legitimate this kind of transdisciplinary approach for studio development and studio learning.
Thank you. Are there any other questions?
Yes,
okay,
please.
So I'm going to suggest that, yes.
Yes, please. There are plenty of studies using some kind of personality test like the MBTI, the Myers-Briggs type indicator, and software development rules. Did you investigate with this kind of studies?
We didn't use these psychological tests because we were more interested on their historical traits and historical backgrounds. So what were the common background, the historical background? And from that, we derived the personal traits. And for those personal traits, I believe the psychological test would be useful, but we thought that before looking at the psychological traits, we have to look at these histories to see if there was anything in common. So from this concrete experience, we could go to a more in-depth look at the psychological traits. And that's definitely something that can be done in the future.
Because I know that the people from the Lero in Ireland, for instance, they use the grounded theory for a lot of things too, including maybe some competency or traits for software developers. I put one of their paper in the chat. Maybe you know them, those people.
No, we don't know this paper, and thank you, because that's precisely what I had in mind. How could you do some psychological tests in a grounded theory approach which does not, you cannot start from the beginning from a preconceived set of categories like usually these psychological tests do. So I would take a look at this.
Yeah, it's not my work. I'm just aware of this.
Good, thank you.
Okay, so we're about time to move on to the next presentation. Tanya is going to be talking about reflective practice in software development studios, findings from an ethnographic study. Tanya, would you like to present, share your screen, or would you like me to do it?
No, I would like you. I prefer you share it if you have it.
Okay, I do indeed. There you go.
Okay, let's start. Well, I made a participant observation in a software studio that is developing mobile applications. Here, it's me. I participate during an event to commemorate Halloween's Day. And it is important to see that we integrated so much with the group. This environment to me was very interesting and rich, because the people had different experiences, and they came from different areas. They came from design and computer sciences, and all of the students are they have very different characteristics, individual characteristics, and this is very rich to observe and to see the results. And as a result, we could observe that using the reflective practice in the studio, it's possible to develop some skills that are required for software engineering. And the studio environment is very rich, and the skills we noticed it's that could be developed are some attitude skills and technical skills for sure, and some software engineering practicing required skills. It's I would like to talk about this teaser slide.
Okay, thank you very much. So I'm going to open it up to questions. The official discussant is Lalit, but obviously open up to any questions as usual.
Sure, thanks. When I read through the paper, and it was certainly interesting to bring the reflective practices for software engineering. But I did also look at the conclusion on the future work. Is there a reason why you had to limit just to 4 to 6 students? Did you look at, see what practices, what observations would be if it is a larger classroom?
Okay, the studio had 50 students, but they are divided into morning and afternoon, afternoon and night groups. I followed only the groups at the afternoon, but it was impossible to observe so close, more than 2, and 2 of them. I followed the 6 groups that made part of afternoon group, but I only analyzed 2 groups. And one, for example, of these groups, I have to stay all the time, and the other, I have to divide, and I have to record all the meetings. And one of the groups are more close to my intervention or to my observation, and the other was opened to this. So this is the reason, because it was impossible to follow all the groups at the same time.
And what I mean, I'm not
sorry, I did not respond. Why 6 students? Because the formation of the groups are 4 to 6 students each one.
Okay. And while I don't know so much about reflective approach for learning, but is there a basis on which you identified those parameters to identify what they have as a means to reflect on? I mean, I see some 10 to 15 parameters on which you try to get information about the students. What was the basis? How did you identify those parameters?
Sorry, your audio cut a little bit. You asked about the parameters identified.
Correct.
Could you repeat?
What I was asking is, there are parameters on which you try to gauge. How did you go about identifying those parameters? Is there some scientific rigor that you brought in, or this is more of a theory that exists in reflective approach?
Well, I identified some things observing all their meetings. And what I observed throughout the project development, I collected from their meetings, and I code this each discourse of the students, and find parameters, look into the reflective practice concepts. And I look to the 3 reflective practice concepts, and what is the result of, or the immediately, like I say, consequence of that reflective practice concept. For example, reflection in action. After they do a reflection in action, what happens? I was identifying this and looking to the software engineering practice. So I don't know if it's clear for you.
No, that's fine. Yeah. I don't have any other further questions.
If I may jump into this answer, Tanya, you have identified some practices based on theoretical concepts derived from the reflective practice theory of Donald Shun, but you also found some practices that were not directly related to Donald Shun's theory, because they were more like practical skills for software engineering, and also some soft skills that are important in software engineering. So you have started from theoretical and also literature review on software engineering, collaborative practices and best practices and the required skills, but you did not apply this directly unless you really had some evidence that you could code based on these concepts derived from literature. So it's a qualitative analysis with a predefined code set.
Yes, okay. Thanks, Fred. This is why we didn't find all of the software engineering's practical skills that you find in the market or other literature reviews. I find some specifics, and only this I report there.
Sure. Just an extension. I know reflection of what I have learned is also depends a lot on the culture, or what an individual would have been brought up, how they have gone through their schooling. Did you look at if culture, the schooling actually matters in terms of reflecting on learnings? Did I make sense?
Can you help me? My audio, my sound is very bad. I could not understand the question.
Sure. Sorry about that. What I was saying is a reflective aspects of in terms of the culture, and what my schooling would have been, what my brought up has been in terms of reflecting on what my learnings are. If you agree with that.
Maybe should I would like to ask Lalit if you could clarify, are you referring to institutional culture or the school culture, or the schooling culture of each student, the background, the cultural background that they bring to the studio?
It would certainly depend on the school culture as well as the individual culture.
Oh. But the students come from different school cultures. From graduations and universities too. Fred participates, I think, of selection. I don't know if you can talk a little bit more about this.
We did not investigate the cultural background, and unless what you already have seen in Elias Neto work, the previous paper, which did not look for culture but looked for personal experiences. And as you could as we identified, they have some common experiences that might come from some cultural background that we didn't look yet. But I have to say that Tanya chose an ethnographic approach to study this development studio because she wanted to understand culture over there. In culture, one of the major aspects is the everyday practices. And she tried to understand everyday practices related to learning. So she did not study culture in general. She studied practices, which is one key element in studies of culture. So she studied more like institutional culture of the environment instead of looking at the individual cultures the individual backgrounds that people brought from other cultures.
Sure. Thank you.
Okay, so we've got time for one more question. Marian, you've got 2 minutes.
Yes, thank you. From what I understood, this reflective practice is also usually influenced by social skills or social interaction. And there, what would you estimate if you need to bring this to an online format? Would this work, or might there be concerns?
I think reflective practice is natural for us. We use this from some we were a child to learn about a lot of things, and we forgot to pay attention to this in a natural way of learning. So I believe that we have pay more attention and incentivize and promote this kind of practice in our students during the process of learning.
Okay, I'm gonna
just quickly a quick short that after you should look for the next paper of Tanya, because the 2019 cohort was exactly transferred for an online format, and we are looking into that. In the future, maybe we have some new insights if that really works. We don't know yet if it's still reflective practice or maybe some other way of interacting and being together, and that's definitely a key issue for the future.
Super. So I'm going to look forward to that paper, because that is essentially one of my general questions I wanted to ask everybody. So we're going to move on to the next presentation summary now. A software engineering approach for co-learning of virtual labs. That's Lalit. Would you like me to share the slide, the video? Oh, it's a video, isn't it?
Right. Yeah, if you have the video ready, please share it.
Yes, that should be fine. Share.
It's my co-author who has spoken in the video.
Share sound. Okay.
Good morning, good afternoon, good evening. My talk is on SC approach for co-learning of virtual labs. In the current pandemic, did you figure out alternatives to make students practice lab experiments? Do you believe in peer learning, collaborative and cooperative learning? Do you still believe making students view videos or practice simulations is good enough to learn from online experiment? How can we make experimental learning scalable? Traditionally, we software engineers adopted practices from other engineering streams. It is time to say that software engineering practices bring rigor and enhances learning. If you find this exciting, please attend our talk on NSC approach for co-learning of virtual labs. Thank you.
Brilliant, lovely and succinct. Lalit, as that was only 45 seconds, do you want to add anything, or should we jump straight into Q&A?
Yeah, what we have seen is this paper we submitted before the pandemic. During this pandemic, we saw a phenomenal increase in the adoptions, while we don't have an updated numbers, but the usage and the practices that we adopted almost multiplied by 10 times. So it suddenly gave us a lot of confidence that it kind of works. Probably the situation in the world is also helping us.
Okay. So the official discussant would be Frederick, but again, open to any questions. Does anybody want to go first?
Well, if no one has a question, of course I do have some. So thank you, Lalit, and your colleagues for your nice paper. It's quite interesting and refreshing to see how you combine some different approaches in collaborative and cooperative computer-supported learning. And I would like to know something specific about the faculty participation in the learning experience of the students. You mentioned that faculty was marginally involved. They just helped to evaluate, but they did not interact with the students in this virtual lab experiment that you have done with the students. So could you please speculate what would be different if faculty would be there? Because I'm quite curious, and that's definitely a question for online experience. How do you scale up faculty participation if you have like 145 students, like in your experience? How many faculty do you need for each of these learning experiences, and how do they need to be trained to join this kind of experiences?
Sure. Thanks for reading the paper. First, the authors of the papers are faculty, right? So we've been teaching software engineering in the institute. It is incidental that in the experiment we did not involve the faculty of those institutes from where we had students participating. However, we did take a feedback from the faculty to see if they have any observations. The primary reason we did not involve the faculty was we did not want them to be biased, or we did not know which direction we would go. So we said, let's do a controlled experiment with us as authors to be the lab assistants or the faculty. Now, in the last 7 months, there was no way that we 5 could have done for the multiplication or the exponential increase that it is happening in terms of the adoption. We have involved the faculty now, and what we have seen is there is absolutely a lot of resistance of using an online mode versus the physical mode of doing lab experiments, because these are not the typical computer science lab experiments. These are experiments that are related to the mechanical engineering, electrical engineering, civil engineering. However, because of the current situation and because of what is available, what is not available physically, they have certainly adopted it. What we are seeing is they have come back with observations saying that the way that we have designed the simulations is not aligning in all the cases to the way that they have the core structure in the individual colleges. So there are some experiments which they are finding it tougher, some experiments which they are finding it simple, and about only 60% of the cases where they felt the courses are aligned to what they have been teaching in the colleges.
But do you think that faculty presence in these learning experience is something that is not required? I mean, I'm asking this question because there's definitely this political discussion on some faculty here in Brazil that are believing that they will be fired and replaced by these cooperative, collaborative environments. And how do you see that?
That's an interesting question. And in fact, when we did the initial workshop in March, there was that resistance saying that would their job be at stake? And we have never approached in that approach saying that a teacher can be replaced and the teacher is always required. So in the Slack environment that we have today running, the faculty are already participating and they're assisting the students either through Slack or their own social media channels. So yeah, the initial few days, there was some kind of inhibition or inertia saying that probably they will be made redundant because it gives a bigger scale. I don't think today we have realized that, and we have not seen any incidents where the college management has fired faculty.
Okay, good. Does anyone has a question to jump in? I still have some left, but anyone? All right, I'm going to move to
I certainly have one, but if you
one.
want to go first, that's absolutely fine.
Well, mine might be very short then. Do you consider, Lalit, your experiment as an example of a gamification in education or some kind of Ludi experience? Because you mentioned points and rules and something that remind me of gamified, but you didn't mention that in the paper.
We actually thought about these serious games. We thought about the gamification part. Yeah, we didn't want to make it sound silly because that might bring the take away the rigor or the practices. While software engineering and gamification are getting more practice, or gamification is being practiced more in software engineering, either in code reviews, in testing, etc., etc. We had a view, but we didn't do any further study with gamification. The way we approached is, yeah, there is a virtual lab, there is a points in terms of reviewing the effort or grading the students, but not in the aspect of gamification. That's a good
Thank
point.
you, Christopher.
We did not take that approach at all.
Would you like to join?
Yes. So you've talked about some of the benefits or experiences of this co-learning approach in virtual labs. And again, I want to try and spin it on its head for discussion point. The purpose is, what are the negatives of doing this sort of approach that you've seen?
It can never replace the physical lab experiments, right? What we also saw,
why?
Some of the cultural aspects, where there are people, irrespective, they would not be opening up. They would try to get away from participating anything on online. Third, we saw when we started with 145 students, we had to bring down, or some of them actually not bring down, but some of them moved on because we did not enforce for programming. We said even testing is fine, even identifying issues is fine. But the moment they realized it has to do something with programming or computer science in general or issue identification, they were overwhelmed just with that thought. We could have made it simpler, saying that, yeah, you would write it like a statement, or you would just send it in an email, or probably, I don't know even if email would have worked or not. We said, yeah, log the issue in the GitHub. That probably put off some people.
Sure.
Yeah, there was also some amount of programming. Some people who are non-programmers have done exceedingly well, but yeah, that certainly put off some people.
Mm-hmm. So I think this is a very interesting conversation to continue. Just more generally, the idea of, go back a few years, everybody was talking, media was talking a lot about MOOCs going to be replacing universities. And I knew my position was very strongly against that, because it's my experience, my research was telling me it was the opposite. But they do work in some cases. And we're now in a forced situation to experience that together. What about scalability? So, a challenge with many studios, because they're quite personal. You've got this coaching aspect to it, and when you start doing a coaching or more apprentice style thing, you can't suddenly take on hundreds of students. So an inherent issue with studios is that they can struggle to scale. Some people work through it. Did you see anything about that?
Yeah. So one thing that we take the pride at the Institute is, for the last 10 plus years, the Institute IIIT Hyderabad has been on the top 3 in the GSOC, the Google Summer of Code. So I don't know if it is incidental or coincidental or some rigor that we brought in at the Institute. So some of our learnings, some of the authors, including myself, have been a GSOC student and a mentor. I think that certainly helped. The limitation that we saw in the GSOC is it is rigorous and it requires a person to be of certain level of competency to participate. In this approach, to make it scalable, on day one, we said we don't care what the person has capability. While there are some people who might drop off for whatever their reasons, to implement the scalability, we just open it up to anyone who wants to participate. And if there is a college and that college faculty wants to take up the challenge, we create a group in the Slack channel so that it becomes a self-regulated or a group that can perform on its own. While we did not go in the last 7 months to look at individuals trying to do or trying to analyze their comments, trying to analyze their behavior, from a scalability perspective, it has been working because our numbers increased 11 times to what we were doing. We did not analyze the comments. We did not see what their contributions. We did not see what is the quality of the contributions. All we saw is the number of issues that got logged, the number of issues that were getting enhanced. The usage of the virtual labs is what we have as numbers. But yeah, we did not do any qualitative, quantitative analysis of the data. So I'm quite confident that scalability can be worked out.
Okay. Right. Well, thank you very much. I have more questions, but we've run out of time. So I'm going to thank the presenters and discussions. That was very, very interesting, very good. Hopefully we can have a 2-3 minutes bio break before the next session on, I think it was industry orientation. So yeah, round of applause for our presenters, and we'll see everybody in a few minutes.
Thank you. Bye-bye. Ciao.
Thank you. Do you stay in the same channel here? Or?
I think it's going to be a different channel.
Okay. So step out and in.
Well, we are in both channels actually. I have seen where it's just the same
channel.
Yeah, I think it must be the same channel. At least the main page pointed us here.
Yeah, that's true. It was in the morning session the same.
Yeah,
sorry, it's the same channel. We're sorry. The between breaks, it's always the same channel. It just looks like it isn't.
Okay, so we can stay here.
We can stay here. We don't even have to do anything about the stream. We'll just keep going.
Yeah.
Oh, hi, can you hear me as well?
Yes.
Yes. I'm on the channel. Can people hear me?
Yes.
Great.
Right. Good. That's a considerable improvement on yesterday. When I had what I believe is known as a thanks Bill moment. Okay, so how many participants have we got?
So Francis is hidden in the cloud.
Oh, thank you. You didn't see me waving.
Yes.
We take privacy seriously. Is our first speaker here yet? I didn't see him in the list.
That's what I'm looking to see.
He's hidden his name.
Ah, he is.
All right.
In case you're looking for me, I'm here.
Right.
Very good.
So in that case, let's start straight away. The first paper of the three in this session. Perhaps I should introduce myself. I'm Tony Cowling. I'm chairing the session. So the first paper in this session is entitled "How Well Does Undergraduate Education Prepare Software Engineers? Perspective of Practitioners in Bangladesh." And I think it is going to be Ishtiaq Hussain who kicks us off with a brief introduction, and then we'll hand over to the discussants. So, Ishtiaq.
Yes, can I share my screen?
Yep, sure, please do.
Okay, can you see my screen?
Yes.
Yep, that's fine.
With the slide, yeah. Okay, so thank you for attending this session. I'm Ishtiaq Hussain from Pennsylvania State University at Abington, and this work is in collaboration with University of Dhaka and University of Toronto. And these are the authors. So since I have only 2 minutes to give you a teaser on this, so let's talk really quickly what we did here. First of all, we did the first ever ethnographic study, retrospective study of practitioners, meaning those who are working in the industry. And we asked them, okay, look back, tell us what you missed, what you do at your workplace, and what you wish you had in your undergraduate studies. And we also asked them, like, compare what you learned and how helpful it was. So we started off by asking, practitioners in our network. Then we snowballed to 20 practitioners. And then we came up with their common themes and the struggles that was mentioned more and more. So then we prepared a survey question and circulated it throughout different channels, networks, and we got more than 200 plus survey participants' data. And the results clearly showed us that there is a gap, and the practitioners as well as the survey participants provided us with very good insights on how it can be improved. Now, one thing I really want to mention on this, not in this teaser slide, but in this slide. It has been studied. The same problem has been studied by Lethbridge, started in 1998, and then progressed to, until recently, 2017 and 2019, where the Corman and others, they have studied 2 years long study on what kind of tools industry is using. They studied more than 1,500 projects and products worldwide and came up with these hybrid methodologies and tools. Then they also studied the educators, like faculties like us, who are supposed to teach their students about these tools. And when they surveyed their educators, they got good response, meaning that educators think they are teaching their students these tools and techniques, and they're well equipped to go to industry and contribute. However, what was missing in our perspective is the customers. In this setting, the customer are the students who are going to the industry and working for companies and applying their knowledge. So what about them? So that's why we came up with the idea, okay, let's ask the real customers, real stakeholders, and ask them if they think their study was meaningful and helpful. And we can discuss about the results, but very quickly, the results show that they are not happy. Let me just show this graph, and tell you that what they were saying was more than 50% students complained, or practitioners complained, they did not use any kind of formal testing for their projects in undergrad studies. And they didn't have any bug tracking system. They didn't do any product or project management. So, and they clearly showed that there is a gap between industry practices, tools used, and what we are teaching at school. Now, Bangladesh is becoming a very powerful leader in Global South. It has more than 100 universities teaching software engineering and computer science. There are more than 4,500 demand of the demand, very well demand of software engineers, but we thought Bangladesh would be a good representation of the Global South, but we clearly see that that's not the case. We have still a lot more to work and improve in our teaching undergraduate software engineering course. With that, I'll stop and take any questions you might have.
Okay, so over to Thomas, Rudiger, and Francis for the discussion.
Yeah.
So maybe Thomas speaking here. I have a clear question on that. So what is, in your opinion, different in Bangladesh compared to other countries close by, like India, for example, with regard to that education system?
Good question. So India, there are some researchers who have already done similar research for India. So in 2005 to 2008, Mahanti and Kirti, they did a extensive study, and they found that only 25% graduates are ready for industry. And there are 20-to-1 ratio on applicant and actual hire. And similar studies were done for Russia and China, and they also showed that their graduates are not ready for industry. So
what have they, because I'm interested in what did they do, because it's quite a long time ago. What did they do to increase or to improve that situation, especially in India, which is close by?
That's we didn't include in our study. Our study was mainly to see what was missing and what the educators, what the students or practitioners think should be done. We haven't done a study what India did.
And especially to that, you mentioned that at least a certain percentage is happy. So what is different to the people who are happy compared to the other ones who are not happy?
Again, thank you for the question. We asked the practitioners what helped them to succeed in industry. Some of the things they said: internship, open source coding, practicing SEM programming contests.
Mm-hmm.
These are the main three themes that came up over and over for the successful software engineers. They said that helped them more than their study in the undergrad.
Okay. Yeah, thank you.
Sure.
Maybe thinking also about India, a couple of years ago, 8 years or so, we made a software quality benchmark where we had also talks with a big Indian company, can't release the name due to a non-disclosure agreement. But they said they do not find enough people on the market. So they hire everybody who has some interest in IT, and then they give them an education on IT. So it was just the pure number. But anyway, what your study said reminds me also on my own education as an electrical engineer. I had a similar thing. I learned a lot about theory in electrical engineering, also programming, operating system, stuff like that, everything which is needed to design a computer, from VLSI design up to application programming. But of course, I had to learn also to use the tools which we used in the university, and we did also some testing, but we did not learn the formal things. For example, you may learn some tools, but nothing about safety regulations and all the stuff which is around that, which is often very important in the industry. You know? So there are a bunch of things.
Yeah, and if you notice, Timothy Lethbridge, I think he's in this conference. He's the first one who studied similar study back in 1998, and he found like testing, the first very thing here, testing and QA and process is missing in industry. And after all these years, we are still finding the same issues. And in Microsoft, as Brackner studied in 2003, Microsoft hires the greatest, if not greatest, the smart people, right? And he found out that even those hires, they need to go rigorous training before months they're ready to contribute to the code base. So like when I was doing the study, we were like thinking, this has been done before. People are complaining, finding the same problem, but we're not doing enough to solve this problem. It seems like it's carrying over years after years, and we're still there to reach. And one last comment I want to make is that one of the practitioners made a very good comment. He said, it's not that the university should teach us all these tools and techniques and formal language, at least help us learn to learn ourselves. Let us know that there are tools and there are challenges out there that we will face. We are in a bubble. We are thinking that we are learning a lot, but that's not the case when we go to the industry. So preparing the mindset might be a good thing we should consider when we are teaching these courses to our students.
And by the way, that was the main learning for me. Universities teachers learn how to learn, because it's important in the university. One thing made me curious when I was reading your paper. You interviewed the practitioners and also the students, which later on worked. But then you mentioned there are 10,000 graduates and 5,000 open jobs. And still the recruiters say they do not find enough quality people. So did you also get a picture from the recruiters? What are they expecting from the people coming from the university?
So our interview practitioners, some of them were like, give me a second here. Some of them were managers. So yeah, this slide. So 25% of them were 5 to 10 years experience who are working not as recruiters, but managers who have a like important say in the hiring process. They were saying that the main thing they are missing is that, as I said earlier, adaptability, knowing the trends and technologies that are used in the industry. And finally, one common theme was communication skill. Students do not know how to work in team environments, how to communicate. So that was something they reported. And again, not specifically recruiters, but managers. We had managers in our survey interviews.
I'd like to pick up this.
Yes, I was going to ask Frances whether she had any questions.
Yeah, it's good if you keep this slide up. In the beginning of your paper, you mentioned that there was a lot of computer science and engineering curriculum a while ago, and that starting in 2008, it had really explicitly software engineering curriculum. But in this survey, you focused on undergrad in general. I think it might make sense, or maybe you considered to subdivide and to compare the software engineering curriculum persons versus the computer science curriculum persons, and to compare those two communities. You compared here male and female, but I think an interesting comparison, or an more interesting comparison, could be software engineering versus computer science.
That's a very good suggestion. We will definitely work on it. But the problem with Bangladesh is that it's very, at least 2 or 3 universities that I know, they have software engineering undergraduate courses, and there are some reported the others are offering, but that's a very good suggestion. We have not done that, but definitely that's something we can do in the future.
Thank you.
Okay, the time is ticking on, so I think we need to move on to the second paper, please. And I'm not sure, yes, I was going to ask Ishtiaq if you can unshare your screen. And I'm not sure who's going to present it briefly. Right.
So I will start and Thomas will go on. So yeah, we just hear the university does not fully prepare for practice. And one big issue we identified in our company was the lack of know-how regarding architecting. And due to some issues we had in very big projects where some tens or some hundreds of people were working together on the same software, we started to develop a senior software architect program to give these people also some in-company education on especially this topic, with also a broad range of topics. It's not only about architecting, the technical stuff, also about business understanding, requirements engineering, testing and quality, and especially social skills. And later on, we improved, or we further developed this a bunch of additional trainings, for example, a software architect training, and then later on a system architect training for mechatronic systems, and a test architect training. And you see this evolved over time, especially for the software architects. This covered in the end a lot of people or participants. So we made also localizations. We have courses in the US, in India, in China recently. Yeah, and you see on the top right of this page, there were many people involved. Yeah. So it's also, I would say, if we include everybody which was somehow involved in the development, it goes around 100 people or so. The driving people were Frances, which is here in the call. She was heading the software initiative and was the main driver of the whole curriculum. And Thomas Blum is a teacher in the software and senior software architect program. I was the lead driver for the system architect program, Peter Zimmer for the test architect program. And one key requirement for all these people which developed this program was we wanted all the teachers to have several years of experience. So they should be experienced experts in their field. So we don't want to have PowerPoint trainers, but we want to have people who can tell from their experience in the field. And Thomas?
Yeah, that's also my role in that training. So I'm also did run through that senior software architects training more than 10 years back. And right now I'm a trainer for the software architect program, what you see on the blue side, the blue level, and the red level, the senior software architect. What I realized, walking through the other presentations in that slot is that our target group is completely different. We have, and you see below that, this basic training. So if we have a new employee in our company, usually she runs through a basic training, and after some years, and 5 to 6 years, he will or she will come to that level of the blue level with the architect, system, software, or test architect. And even it takes more than roughly around 5 to 6 years to reach the level of the senior software architect. We discussed in that paper the architecture of that program because it was very, very important for us to keep track of the fast-pacing world. So what you see on the left side with the DevOps, that's exactly what we have embraced. So in our approach, the trainers also design the lessons. You build it, you run it. And we follow a kind of agile approach by starting with small experiments of new sessions, of new technology, new methodologies which come up, and then in the end, bringing them later to a session, to a real session. Finally, what really hit us hard was the COVID-19 restriction. And that brings me to a basic question, what I also wanted to ask before. Can you really teach software engineering and software architecture, or do you have to experience it? And that's what we are doing. We let people in the trainings experience on their daily work projects how to do architecture and how to do software design and engineering. However, enough of our words. So let's go to some questions from your side.
Maybe just one addition to the last statement from Thomas. Each of these courses is a mix of on-site courses, between 3 and 4 weeks. And in between, we have practice phases. So people get homework. They have to do something in their own projects. That's a prerequisite for all the course participants. They have to be active as working as an architect in the project so that they can immediately apply what they learned. And in the next workshop, we do a review on that and discuss the learnings from that. So it's a mix of theory and immediate practice.
And especially what enforced the learning was that we also have several certifications. In the senior software architect program, we have 4 certification phases, which really forces people to drill down to the essence of software architecture work.
Yeah, so any questions to that? And I unshare.
Okay, and the first question is Syed Wakarnabi with us? I can't see his name in the list of participants, but I thought I had before the session started. Syed, if you're there, please would you speak up? Nope. Okay, that sounds like we have an embarrassing gap.
And everybody else can ask questions.
Yes. Well, I had a very simple question. I came across an acronym in the paper, PLE, and I wasn't quite sure what this signified.
This is product line engineering, or this is what I always say, controlled reuse. So it's not reuse by chance, by copy paste, but controlled reuse where you plan to reuse something, where you build up a core asset base or even a platform, which then is used across several products or product versions over space and time. No?
Okay.
And the essence of the paper is that we do that not only in our products, but we do that for our training artifacts. So we applied this product line engineering kind of reuse to be able to reuse parts of the software architect program in the system architect and so on. And that's why it's called, the architecture of the architect program.
Right, but so that's reuse of the training. In the exercises that you're asking the students to do in the course of the architecture program, are they also having to explore issues of reuse?
Yes, for sure. And the exercises, how you call them, are not artificial exercises. So we always select projects out of the participants group. So they work on their daily projects, and usually the participants are only Siemens internal, for Siemens worldwide, but Siemens internal. So we can openly speak about our projects, and they most probably all of them have large projects which are deep into product line engineering and reuse on a broad scale.
Yeah, and for example, we do also the sessions in the courses. No? One pattern we use in this PLE environment is the BAPO model. It's about business, architecture, process, and organization. So it's again about the holistic view on reuse. No? It's not only a technical thing, but you also have about the business factors behind it. And for example, for the system architects, we have hardware and software, and we work on what are differences. In the software world, maybe there are other business drivers than in the hardware world. In the hardware, you have to think also about production, about spare part concepts and stuff like that, which also drive business attributes in the end. And you have to think about it. Does it make sense to invest in reuse elements, which are usually more expensive than non-reuse elements? And you have to invest a little bit in the beginning, but later on, you may gain something, but it depends on your business case behind it. And architects have to understand that.
Yeah. So perhaps the obvious question is, are you so far in the program you're running, are you so far beyond what you would expect students to have learned in their undergraduate experience that almost it doesn't matter what they've studied? Or do you find that there is a difference depending on what they have studied previously?
So I think the most important thing is what they are working on currently. So usually they enter one of our programs, what we mentioned here, after 5 to 6 years working on that job. And we have also some entry-level interviews where we try to find out, are these guys really up to the challenges of that training? And basically we have people there who studied computer science, medical engineering, several things close to IT, but even mathematicians, because they were working on that job on software engineering for quite some time.
And when we discussed about these massive online courses in the recent sessions, one idea came up. There's a big difference between, I think, lecturing in a university and in industry. In our courses, we have a limit of 16 people in these courses. And that's because we intensively work together. And also this entry interviews and entry process, we really select the people who are allowed to go into this training. Not everybody can book this. So they have to show that they have, for example, software system test architect programs, at least 2 to 3 years practical experience as a system architect, because not only the teachers tell them something, but we want these people also to exchange experience. And that's very important. Yeah? All these people have learnings, something when was working good. They have also war stories where something was not working good, and they should, or they shall exchange this. They shall discuss also what kind of tools are they using, what was the experience with that, and so on. So this is a very important factor, and therefore the course only not stops with the end of the course and the certification. But once a year, we invite all the course participants across courses for networking events, so it goes on over time. We also have wikis where we collect information and experience. This is our core knowledge base for the architects and so on. There are a bunch of measures around the courses so that we build up a network of architects in the company over time.
Okay, and so to clarify, you've got 16 students in the course.
Yes.
Are those 16 working as a single team on one large project, or are they working as several small teams on separate projects?
No, we intentionally want people from different organizational units so that they can exchange experience, so they are not working on the same projects intentionally. And we want to have the mix of the people from different business units and across the world. We have people from all the countries where architects are working, and people from health engineers, from mobility, where they develop trains, from maybe power generation recently, which is now out of Siemens, or building automation, industry automation. So from very different domains, working on different kinds of projects, work in different environments, and they all come together and then they start to exchange. And this is what we intentionally want. We do not want to have people from the same group in these courses.
And just to make sure, in the training itself, they have also to do some exercises working on project. So we select out of this heterogeneous worldwide working group several projects, most of the time by 16 people up to 4 projects, and they work on these projects. And we by intention take people from completely different domains like mobility, like industry and health engineers together to let them work on that project of one of the participants to get in the understanding of how the other domains are working inside the software architecture.
I have a criticism for your work, if I may.
Mm-hmm.
Sure.
So Gerhard yesterday in his talk from TNG said, I'm finding some similarities here. He said we should not, learning should be project-based. Mm-hmm. And you mentioned at the initial stage of your talk that software engineering has to be experienced. It cannot be like, why should we teach it? Mm-hmm. And you also proposing that your course is suited for people who have at least 1 or 2 years of experience. My question is, in that case, how can we benefit from your curricula? We are bounded by this 1 semester worth of course. Students are still learning. How can they experience your curricula and get ready for the industry?
So basically, to experience, yes, they would need to be part of Siemens. That's one thing, but yeah, at least you can get what we see very often is that people entering our company. That's exactly what you mentioned with your experience in Bangladesh, that the training they get is not sufficient to let them really freely work on a project from the beginning, and that's something what we emphasize with having internship, where we have small projects where only 2-3 students are working on, but they are governed by us. We go into the universities and take projects with us, and let complete teams inside university work on these projects. And last but not least, if someone enters our company, we have these basic training programs where one part is training on the job, really doing the work, but also getting just some experience in how our parts of the companies are handling software design, software engineering, and software architecture. And after some time, and 3, 4, 5 years, they can enter this curriculum, like also a kind of career path. So even if you enter our company, you already get the information. This could be a career path for you to become a lead architect in our organization.
And there's also some connections to discussions we had during the last days. One is Rick Hessman always mentioned you need a method because that gives you some guidance. And of course, you have to bring in the creativity and so on in learning. And the other is it's not only about architecting, it's also about other things. You saw it also in your own project, and you need knowledge about testing, you need also the social skill stuff, you need the business understanding. This is something that should be given to the students as well. Gerhard.
Mm-hmm.
I also have one comment from my side,
okay.
is that also the audience of this presentation is not only universities, right? It's also could be other companies also considering to establish such programs in the practitioner, but also for the case that you were describing in your university experience at Bangladesh, some of the things in our paper about how some more technical oriented trainings or aspects could be done in online form. So maybe at your university, maybe you do some more of the technical things, looking at MOOC kinds of setups, and do more social skills and the soft parts in-person project experiences together. So being able to do it that way would be an additional split.
Right. Yeah. It looks as if the presenter of our third paper is not here, so it's going to be very difficult to have a meaningful discussion about that paper. So I guess it's going to continue with just discussions of the two papers that we've been looking at so far. So Ishtiaq, you had a question.
I think Gerhard raised his hand before me, so I'll just get
what I think is interesting is how these things are taught at Siemens, because what they do is they really work together as a team to create a curriculum. And I'm not so sure if that is done in a similar way in academia. So that's also probably a point to have a look at how these things work together and how they are made practical in a way that the results are really meaningful in a way. So I think it's really interesting how you create something with practice and some theory and reflecting and to mingle the people and so on, do this together. So there's several aspects on that probably might have an impact on academia as well.
Yeah, and that was very important thing to combine many experts. I'm not a testing expert, so I'm involved a test expert also in the program, but we involved also people from the business unit who could contribute with war stories, with experience, which we bring in as examples in the courses. As you also mentioned, you hire talent, which you said, and give them the knowledge in the company. This is a similar aspect. And when I developed the system architect program, we had already a couple of years experience with the software architect programs. And this is one important method in the PLE environment. If you want to do controlled reuse, then you start with a commonality variability analysis. What is common and where do you have variability? And so I also analyzed what is common between a software architect and a system architect, mechatronic system architect, and where is the difference between them? And there are some commonalities. Both work as an architect and need some specific methods for that. But there is also a difference. For example, from our software architects, we expect from them that they are very experienced software developers, that they can coach a software developer down to the bits and bytes in tooling and in coding structures and so on. You cannot expect the same thing from a system architect, because we have, for example, if you take a blood analyzer, you have mechanic and electric and electronic and hydraulic and biochemistry. One person cannot be the expert in all of these disciplines. It's not possible. So system architects are usually on a more abstract layer, but they need to understand all the experts in all the disciplines. So they have to make them work together as a team. So they need, of course, a certain knowledge in the terminology, in the issues of each of these disciplines, also in the different culture. There's a different culture from mechanic people and software people. and you have to make these people work together as a system architect. I was in this role, I had to do this. It's not easy to do this. And so this influenced, of course, also the content of these training programs.
Okay, Ishtiaq.
So, Francis mentioned about MOOC, Massive Open Online Courses. So I'm wondering if you have your basic training program that you mentioned, if that is already a MOOC, or are you planning to release that course for everyone?
There is, we call this My Learning World. There is a kind of broker platform where we provide a lot of virtual trainings. For example, a contract with LinkedIn. We have more than 16,000 courses from LinkedIn on this platform. So there's a lot of possibility for such learnings also. Yeah. And this surrounds also the architect programs, and it is an entry-level thing.
Yeah. And it's more things that already exist, from other providers, because it's more about the technology, right? And we want to be able to, always be able to move to the next technology. It's very important for us to be able to have this evolution, right? And we want to invest our time and effort into the parts that really will sustain a long time, and the technical things that change, we want to be able to bring in and phase out when we move on to the next technologies.
Yeah, and there's a big difference, which I see. If you want to provide knowledge about how to code something, about a software language like Java or something, then e-learning works very good. But if you want to drive a mindset change,
exactly,
then virtual training is not the best thing, or not the best thing. Then you need more classroom trainings.
Yeah, if I can inject a little bit of personal experience, I mean, I'm retired now, but for the last 2 or 3 years before I retired, the main thing I was doing was running team projects for what would be the equivalent in our program would be the equivalent of the junior year in a US structure. Small teams, 4 to 5 students, working on obviously fairly small projects, but for real clients. And in fact, most of my time was spent recruiting clients and then basically overseeing the colleagues who were helping me to manage the teams. And it seems to me that kind of experience is really what distinguishes a software engineering program from a computer science program, where students I'm going to generalize here, probably quite unfairly, in general, are not going to get that kind of real world experience. And I mean, a question that I wanted to ask Ishtiaq is whether whether he was seeing in his data any difference between the results from graduates from software engineering programs or the results from graduates from computer science programs.
And that's what Francis suggested. We haven't done that study in our work. So that's definitely a future work for us.
And I mean, my personal comment, possibly relevant to the whole topic of this this conference, is that I really do not think computer science programs are an adequate education for students who then want to become software engineers. But how we get that message across to the world, I'm not sure.
I think it depends a little bit on what kind of computer science program or software engineering program we're talking about. I know of some programs who are, let's say, who are more business information systems oriented, and then you have a software engineer that knows he knows things about international law and things like that. And then else you have software engineering programs, especially in North America, that are that still teach assembler and things like that. So and that's the range. That's the range of talent you get, right? And I don't know.
And
that's one.
Ishtiaq, you mentioned, or you asked, how can academia maybe take some advantage out of our training? So something, if I would have a wish to academia, and that's something I see in all our trainings. I'm on the software side, so software architects, senior software architects. The biggest problem, even for people working in the area of software development for quite some time, is somehow a systematic approach, how they really come from a problem they get from somewhere to a solution. And that's what we also see with young people, but also with people in our training. I think Rick Kastman this morning also mentioned that, how you get a description of something you need to realize. And if you tell that, and that's what I'm currently in with some students who do some internship in our organization currently, it's for them very, very difficult to find the right way to come to a solution. Very often they get a first glance, I have to display something, and they immediately jump to the solution. And that's the biggest problem. They are maybe not trained to first think about the problem. And then take some, like Rick mentioned this morning, some tactics, find out something, how you can solve that, to come also up with some alternatives which can be discussed. And that's something which I think could be more emphasized during their studies at the university.
One more question. Is there like any external certification process you recognize like equivalent to your internal program? I mean, I see all the benefits of building the internal expert network that you don't get if you send people to an outside training offered by someone else. And Siemens is certainly a sufficiently large company to build up an internal training. But if we have a look on a smaller company, or is there any other possibility to get like an external certificate or training that you would compare to what you do internally, like in skills, and recognize some skills from what people eventually bring with to your company if they join later?
I think for the software architect program, there's something halfway comparable, but not for the senior software architect program, and also not for the system and test architect program.
Okay.
The impression I have is that generally this kind of certification goes on at a much lower level than you're talking about.
Can you repeat? I didn't get the question.
My question was whether there's some external certification that's equivalent, and Tony made the comment that in general external certifications are way below what you're internally looking for.
Yes, most probably. So our certifications are not really based on knowledge. They are based on capabilities, how the participants can really apply their knowledge in their daily work. So it's not sufficient you take part of the training and you get some knowledge about ADD, what Rick Kasman mentioned this morning. No, our certification goes in the direction that how do you apply, for example, ADD in your projects? How did you handle different problems, different situations we put on the plate for the participants? And that's, I think, not something you get very often outside, because you cannot work on you cannot certify someone on his daily work, because it's something inside an organization you don't have access to as a training from the outside.
And Thomas, I have a comment on your, not question, but a comment, why students jump into the solution rather than thinking about the problem first rigorously. I don't know if I can speak for 1 minute or 30 seconds, or should we just take it offline? So
yeah, I think about 30 seconds is all you've got.
So
there's a networking session that I would invite you to go in and continue if you want to.
Yeah, we can also have a discussion later on. Yeah, no problem.
Okay, well, thank you very much to our speakers.
Thank you.
And I think we have to conclude at that point.
So I just wanted to really apologize. I completely mixed up the time zones. So, yeah, so I don't know if you can see my face red in the screen over there, but my face is as red as it gets.
So it gave us more time for discussion.
Yes.
So you were very gentle to spend the time.
that was a silly blunder, but really sorry. Yeah, I noted some other time zone, and I just assumed.
Oh.
Okay, so thank you to everybody.
Okay.
Okay.
Yeah, thank you.
Thank you.
Bye.
Bye.
Stay here for the next sessions. That happens right now in the same Zoom room. So if you're leaving and you click on the other one, you'll just wind up right here again.
Thank you, Bastian. So I will, it's 9:30, so I will continue. So my name is Pierre Bourque from École de Technologie Supérieure in Montreal, and I will be chairing this session called Teaching Programming and DevOps in parentheses. So we will begin with Vladimir Borbaric. His paper is titled An Observational Study on the Maintainability Characteristics of the Procedural and Object-Oriented Paradigms. And this is a paper from, we have a number of countries represented in this session. I thought it was interesting. We have a paper from, from Ecuador, one from Germany, from the United States, another one from the United States, and from the UK as well. So we have a nice international representation. That's interesting. And we have some papers, I would say, at the course level on introductory programming and programming courses, and we have some papers also more, I would say, at the program, at least one paper at the program level. And so I thought that was interesting. And also, with some of these papers present, I always find that interesting, some counterintuitive results or some surprising results, which forces us to think a little bit more. So that's also very good. So Vladimir Barbaric, are you online?
Yeah, sure, I'm here.
Okay, so I will share your, do you want to share the screen? You show your teaser slide, or do you want me to do it?
Yeah, I can do it.
So go ahead, and you have 2-3 minutes to present your teaser slide.
Yeah, can you see it now?
It's coming. And Axel Butcher, are you there?
Yeah, that's me. Yeah.
You're here. Okay, that's good.
Okay. Yeah, so should I start?
Go ahead.
Okay, so well, as our presenter said, the paper I am here to present is the observational study on maintainability characteristics of the procedural and object-oriented programming paradigms. I developed this paper as part of my graduation project for my bachelor's degree on Universidad de las Fuerzas Armadas ESPE here in Ecuador. So we also have a collaboration with Stephen Clyde from Utah State University, and his input was really, really great. So well, I want to preface this saying that part of the motivation of this investigation on programming paradigms is comes because they are taught really differently not really differently, but kind of poorly in our university, in our curriculum. They have not too much attention to programming paradigms. So because, well, everybody's keen with object-oriented programming and Java. So the motivation was to try and investigate what other programming paradigms could offer, right? Yeah, so we compared the two most widely used imperative programming paradigms, so procedural and object-oriented, right? So these kinds of comparisons have been made before, but we wanted to take a different approach to them because, well, maintainability is a human activity. So rather than comparing the code itself and the programs and developing metrics to compare code and writability in the code, we decided to go the experiment route. So we use the developers to measure maintainability speed and effectiveness. So we designed this experiment that simulates a situation that a developer might encounter like in real life while maintaining code. So we had a really great sample of students, not that large, but we had 3 different levels, the beginners, intermediates, and super seniors that were like 1 semester from finishing their degree. So when we gathered the results in the end, we found some counterintuitive things. So mainly that procedural programming yielded better results on average. So 80.3 more effective. The students were more effective using procedural, and they were faster also using procedural, right? And that's what's counterintuitive because, well, first of all, the students had more experience with object-oriented programming because all our curricula was based on object-oriented programming, like from the first semesters to the final ones. So there are several reasons why this study produced these results. So mainly because it was intentionally limited, and probably because the experimental object is only representative of just one kind of software. And also we needed a third party to validate like the experimental object. So we were not introducing biases in there. So, well, in the end, our conclusion was that we think is worth investigating further into this topic, right? To try and rank the maintainability characteristics for each programming paradigm and maybe include more kinds of programming paradigms like declarative programming paradigms like functional and logical probably, because they are not widely taught in our context, in our degree in our curricula. And maybe this will generate an advantage for students like going out on the industry, because if they know what maintainability characteristics they can use or they can leverage from different programming paradigms, they may want to take better decisions. They may take better decisions on that. So yeah, that's a really brief overview of the paper. So now I am really open to questions if anyone has one.
So the discussant for this paper is, please forgive me if I don't pronounce your name correctly, Axel Botcher. And so the floor is open to questions to all, as in the previous session. But of course, please, Mr. Botcher, you also, of course, are invited to ask questions. So I see Mr. Mueller is diligently raising his hand, as a very good student, waiting his turn. So go ahead, Gerhard.
How large were the example projects or products? Because I think if it's better or not depends largely on the size, on the complexity of the domain and the system.
Yeah, so that's one of the threats to validity that we posed on the paper. The project was really small because these were students, and we had a time constraint to run the experiment. But also we included the links, so the project is publicly available on GitHub if anyone wants to validate and to see for themselves what kind of program it is. But they were kind of equivalent, so you might want to say that procedural works for tiny, small projects, like into microservice context, you could say. But yeah, we need to investigate that further with larger experiments.
Thanks.
Yes, go ahead, Axel.
Although you mentioned that the results were surprising, the students had more experience with object-oriented programming, and you found they did the maintenance better for the procedural parts. But could you comment on the previous education of the students involved in this study? So I still have the opinion that there is a bit of bias, since the students all of them are not really very experienced. I think the most experienced group are 8th-semester system engineering students, but they are not really into software development and software engineering. So maybe there is still a bias due to prior education.
Yeah, so I might want to clarify that systems engineering in Ecuador in our curriculum, it's kind of a mix of computer science and software engineering. So the name is kind of misleading. So yeah, I might want to clarify that, because yeah, right now, we really phased out that kind of curriculum, and we split it into two, like software systems engineering now is software engineering and information technology engineering. But yeah, but that's a good point. The students were really not that experienced in like real world scenarios and programming of large projects. That's why, to like try and keep it fair, we introduced a training. So we trained both students, all groups of students in both programming paradigms, like from an equal time and an equal like kind of curriculum that we design ourselves. So we try to mitigate that kind of bias from the experience, like training them previously.
Any other questions? Yes, Ishtiak, go ahead.
So I was wondering, how do you measure or evaluate maintainability? Like one group, how do you say this group is better in code maintenance than the other group? What's your metric for that?
Yeah, so we developed these metrics on maintenance speed and maintenance effectiveness. So those metrics are based on maintenance tasks. So we gave them like a document with maintenance tasks that they need to develop in a span of time. So they, when they were developing the tasks, we measured the time that they took to complete them, and then we measured the correctness of the task. So we had a set of automated tests, of unit tests. So we run the set and we say, okay, the testers are passing or not passing. So in the paper, we had a formula in which we calculated like, okay, this is the speed, this is the effectiveness, and then we could measure it effectively and objectively.
Gotcha. Thank you.
Yes, go ahead, Mark.
Hi. Yeah, so I think this is really interesting to see. I am curious, are you noticing that certain types of maintenance tasks, maybe they do better with procedural versus other types they do better with object-oriented? And then it could be somewhat the weighting of those tasks that's also affecting the result.
Yeah, that's worth investigating. We could devise another experiment to do that. That's another problem we posed on the paper, that is that the set of maintenance tasks was really small. So we don't really know if that was an effect. So probably we choose a set of maintenance tasks that was really favorable for a procedural programming and not for object-oriented. But yeah, we should, like, in our future work, do that. Certainly it's worth thinking about.
Okay.
Yes, go ahead, Axel.
Another question. Could you also comment a bit on what we can learn from your study regarding our teaching? So what can we take from it for our teaching in future?
Yeah, so maybe stop it with Java and object-oriented and try to include more and more variety of things. Because yeah, when I was reading also my discussants, the paper I need to discuss, and I see her laughing in the in the screen right now. Yeah, I saw her that they also use Java, and I am like, yeah, I thought that it was only my university. So yeah, maybe try to spice it up and try to teach new kinds of new paradigms, new ways of doing things, instead of sticking with this one that has been proven like is really nice. But yeah, we need to broaden the teachings or include it in most ways.
So I have a question. First of all, I want to understand correctly. This paper results from your graduation capstone project. Did I get this? If I had an undergraduate degree, did I get that right?
Yeah. I recently graduated from my bachelor's degree.
Well, first of all, I'd like to congratulate you on having a paper, getting a paper published at the end of an undergraduate degree is an accomplishment. So first of all, I would like to congratulate you. And that's quite an accomplishment.
Thanks a lot.
And
thanks a lot.
But it's not very common. But my peer review conference like this one. But your paper presents a very well constructed experiment. It's very well thought out. I mean, obviously we can debate the specifics of it, but a well thought out experimental approach. How did that fit? Why did you choose such an approach? And did you have a course on that and in a previous course on that? Or I thought that was the most interesting part of your paper.
Yeah, so we didn't have a course on this kind of experimental software engineering thing. The thing was that I am really keen on procedural programming. I love procedural programming, doing that kind of stuff. And all my teachers, including my thesis director, which is a co-author of this paper, all of them told me that no, you shouldn't mess with that. And I was like, well, I need to test it. I need to know. So there was this teacher that recommended this book that we based the entire method of, which is Experimentos in Ingeniería de Software from María Genero.
Yes.
So yeah, so we use that as our baseline. So we took pretty much all the guidance from that book.
This is more like a recommendation from a professor and a personal initiative. You did not have prior training on this in your undergraduate degree.
No, absolutely not.
Okay, thank you. We shall move on. Thank you very much. And maybe there's lots of syllables in your name. Perhaps you can tell us how we pronounce it to complete this.
My name.
Yes.
So Vladimir Berborich. Yeah, with the E, but the E is not written. Yeah,
okay.
Thanks to my ancestors. So yeah.
Thank you. So we shall move on to the second talk from, and once again, forgive me if I'm not pronouncing your name correctly. The paper is called Alignment of Teaching and Electronic Exams and Detector of Error Patterns for an Introductory Programming Class. So this is a paper from Germany, and I listened to your video. I thought it was very well presented. And of course, the topic of online exams, and this maybe the paper was done before the pandemic, but the topic of online exams is of course very much of increasing importance, and plagiarism and so forth. And I sit on a committee at my school and we debate this over and over. So I think your talk is particularly relevant in these pandemic times. And just as the previous paper, you also have some surprising, maybe counterintuitive results. So why don't you share your screen, Axel? It's easier, perhaps.
Yeah, I hope you can see the screen.
Yes.
Yeah, thank you very much for the introduction. Yes, we are going from the high level maintenance down to the low level of teaching introductory programming course. And yes, there are also some interesting, surprising results. And yes, this is pre-COVID work, but I think this kind of electronic exams will sometime be able in COVID conditions and afterwards, definitely. Well, here is some teasing or spoiling. So the question was, can we constructively align electronic exams to our teaching? And we found, well, with this sample size of 1, yes, we can excellently assign this when we move from written exams with pen and paper to exams where students work with their IDEs. Can we address learning objectives on different levels? We use Bloom taxonomy with electronic exams. The answer is yes, we can. And we categorize the mistakes. I have not the time to show this here. Which kind of mistakes did we find? Well, different kinds on all levels of cognition, but we were very surprised of the lot of syntactic errors. When we go to evaluation, we ask, do students like this? Because syntactic errors are bad for students. They will get 0 score. Surprisingly, students like this kind of exams. Do teachers like these? Yes, definitely. And well, what is the main source of mistakes? And we have a good indication that students underestimate the effort they have to invest. Well, as often in research on education, we had also another changing parameter starting with the year where we used electronic exams. Students were no longer forced to turn in exercises every week. So they started to underestimate the effort they have to invest. So yeah, that's my teaser.
Thank you. You maybe stop sharing your screen so we can see everyone. Yeah. Thank you. The discussant for this paper is Leah Butler. So the floor is open to questions, but obviously particularly Leah Butler herself. I believe you're online. I can see you with a very smiling face. So the floor is open to questions. Who has a question? Would you like to go first, Leah?
Yeah, I think, I guess just an overarching question. So at least as a student, when I went from my undergrad university to my grad university, I had a student transition from paper-based exams to online exams. Was there like a biggest lesson learned or like biggest surprise from like the teacher's perspective going forward? Because I know that you touched in the paper that there was somewhat of a student expectation that they would get points regardless of what they wrote. And then with a syntactic error, they're going to get a 0. So I was wondering if you had any thoughts or retrospect thoughts.
Well, I made it clear to the students up front that they won't get any score for syntactic errors. And we trained keeping the code syntactically correct at every point of time. So although they were surprised that they didn't manage that, or that they did get a very low score in some cases. And yes, on the teacher side, this was the largest surprise. It was really incredible. Yeah.
Any other questions? Yes, Gerhard.
Hi, Axel. Thanks for the research. I found it really interesting. How often have been the students in a similar situation? So was this their first online exam in this way, or did they have some preparation example exams in a similar way as well?
They did have an example exam in a different topic before the software development exam. Yeah. So I researched 2 subsequent parts of an exam, one early in the semester and one late. And the test exam was also before my first part.
So they had this experience how it should work out in a certain way. So that, for example, with the syntax errors, it wasn't completely new for them.
Yes, they had.
And still they made these mistakes.
Yeah, and we are forced by law to make students familiar with the environment. That is a prerequisite.
Makes sense. Thank you.
Forced by law. What does that mean?
Yeah. But
well,
there is a what do you call that? Vorschrift?
Regulations, perhaps?
Regulation, thank you. There is a regulation that requires us to make students familiar with this exam environment.
Yes, Ivan.
Thank you. No, I was wondering whether you had the chance to deal with any case of plagiarism, and whether any policy in that sense, or any standard way of handling these cases is in place.
Well, I think we didn't have it. Students are 2 seats apart. There's also one PC, one personal computer between 2 students. And we had these tiny little walls made of paper, which we could position between 2 students in addition to that. And also I made a plagiarism check using MROS, and I didn't find any plagiarism.
Stefan?
Hi, Axel. Thanks for this interesting paper. I can confirm your findings, even if I didn't research them, but we just due to COVID also changed to online exams, and we had a large exam. And one benefit was for us with the many students that we have automated tests. And we also told the students that compile failures will lead to 0 points. And most of them expected or accepted this, but many of them also complained afterwards that this is not fair. Yeah, I have the almost correct solution, and just because I have one typo, I get 0 points. And it was a little bit difficult for us to handle this. They also went to the Fachschaft, the student council, and then they made pressure at us because no one is used to this new way of assessing students, in my opinion. What we found a technical solution. We basically used a test compiler from Eclipse that is a little bit more resilient to compile failures, so that if they have a compile failure in one file, then in the other files, it can still be tested and they could still get points for it. But we still had a lot of manual complaints. Did you have the same experience, and how did you react to those complaints of the students?
Okay, thank you for upfront for the hint with the compiler, Eclipse compiler. I will come back to you later. No, we didn't have this kind of complaints. In any case, we could show that there was more missing than just one typo. What we had expected was a missing semicolon due to the time constraints. Our platform, our environment shuts down after 1.5 hours, very hard. And we had expected missing semicolons, but in no case these syntactical errors were easy to fix. All cases were much more difficult than just insert a semicolon, it works.
Okay. And
Yeah,
maybe
yes.
a follow-up. What we also found difficult is, I mean, we thought now they have a compiler, now they have the IDE, they can do much more in the same time. And I guess this was also a problem from the teaching perspective, because some of the students really had a hard time then. I mean, it was not too much, but it was definitely more than writing code on a paper, because then we typically ask for, I don't know, 10 to 15 lines of code. And now we expected them to have, I don't know, 25 to 30 lines of code. And some people were also completely, overdue with that. So I think this underestimation is really something that we have to take into account.
Yeah, they don't exercise too much. They must exercise much more. So you learn software development just by exercising it.
Yeah,
that they must incorporate that. Yeah.
Bastian, I saw that you indicated you had a question.
Thanks, Pierre. Yeah, we had I just wanted to confirm what both Stefan and Axel said. We are in a different environment. You know, it's New York and Germany. Instructions were just different, very different, and we made very much the same impression. First of all, you need to practice programming in order to become good at programming. It's just how things are, and these students perpetually refuse, or let's say don't engage as much as we think they do with the material. And we had a very similar approach to what you did, and had almost the same findings. The one thing I would note though is that in our exams, the person who's instructing CS1 this year applies the similar approach, like I said, but he places less emphasis on syntactic correctness as much, and it's more curious about, well, did you understand the principles? Did you understand the principles behind a for loop and things like and base conditions and recursions and such things? And well, he hasn't told me yet what his results are going to be this fall semester yet, but seemingly we have roughly the same percentage of students who are performing above average and the same percentage of students that are performing below average. The one thing we noticed though, that especially last semester, people were very anxious about their grades, even though they didn't really have a need to be, right? Because of COVID and such and technology shifts. They were just more anxious, even though the conditions for them were roughly the same last semester. Just wanted to share that with you.
Okay, that's interesting. Thank you. Yeah.
So I have maybe perhaps a final question, and I don't see anybody other's hand raised. Were the students aware that they were participating in something like an experiment? And did you have to go get permission from something like an ethics board to be able to do this?
No, the students weren't aware of that. However, I showed them all the evaluations after the first part of the exam to prepare them for the second. There were also some correlations I didn't show now between the effort they invested up before the exam and the result. I showed it to them, and I did not go to an ethics board. I'm not sure if I had to. I didn't do.
Well, in Germany, as a Hochschullehrer, as a university professor, you have something we call Lehre und Forschungsfreiheit, freedom of research and instruction, and as such, you're governed by certain ethical rules, but there's no ethical control board other than in medical fields and such things. In the US, it's quite different, right? In the US, for example, and my institution, I'm a member of the control board. We have to adhere to what they call 45 CFR 46. It's a code of federal regulations that specifically regulates how treatment of human subjects in research. Interestingly, education research like this is permanently exempt. So you don't necessarily, in most conditions, not in most situations, don't necessarily need ethics approval to do a study like Axel did, for example, in the US.
IRA, right? The Internal Review Board. You have to go through. Yeah.
Human subjects, IRB, institutional review board.
You just have to take 2 courses on human subject and the privacy, and then apply.
Yeah, we have to do this too. We have to, when you do this kind of research, you have to be certified that you know CD
And
courses or whatever.
the intention is to improve teaching, and I think that does. We have such a board, an ethics board, but I think I don't have to go to go there with this question. And the background is I want to improve teaching, and so I think I won't have any problem there.
So perhaps one final question. What can we, in these COVID pandemic days where online exams are very prevalent, what is the number one lessons learned about perhaps scaling up this approach to a very large number of exams and large number of students?
Well, I think this is the way to go. When we have a distributed environment where everyone sits at home and uses the exam environment, we have to think about cheating much more than we had in this context. I did not use this type of exam in the last semester under COVID conditions because the technical environment was not really that far that it could be used. I think this is the way to go, and we have to think about cheating.
Thank you,
Our
Axel.
department chair always says if you're able to cheat in your exam, you're doing the wrong exam.
Again, a programming exercise.
Our next, thank you, Axel. Very
Thank you
interesting.
for your attention.
So our next speaker is, one second, I want to make sure I get this right. Our next speaker is Leah Butler, and it's a paper from the United States. It's titled Data-Driven Investigation into Variants of Code Writing Questions. Do you have a teaser slide, Leah?
Yeah, sorry, I got that in late, but I thought we were presenting them anyway, so I guess I'll go ahead and present mine, hopefully.
Okay, so shall we, do you want to present your teaser slide, or do you want to just present it verbally?
I was locating it on share screen. I have a bad habit of having a million things open at once. Can everybody see that okay?
Yes, and once again, I think this is a nice, I would say, follow on from the previous presentation, because we're talking about fair assessment in online exams. So so this is a online asynchronous exam setting. So I think it's a nice follow on.
Yeah.
And certainly very relevant, obviously.
Yeah. So that was a pretty good segue. So the work that I did alongside Professor Tao Xie and Professor Jeffrey Challen was a data-driven investigation into variants of code writing questions. So the overarching questions we asked was, how well can question variants accomplish fair assessment in the context of online asynchronous exams? So online meeting on a computer, and then asynchronous. In our particular context, asynchronous was you signed up for an exam time slot over several days. So students are not necessarily taking the exam at the same time. And then question variants, we define as manually written questions that are put into a pool with other variants. So for the running example that we have is a linked list question where you might want to traverse a linked list. So variants of this might be count number of items with even values, count number of items with odd values, count number of items with positive values, and count number of items with negative values. So we did this in the context of online synchronous exams, like I said, and we applied our investigation of 3 dimensions, which were score, duration, and distribution of effort using the student submission data. And then we see from our results that observable inequalities of student performance exist between variants. And we also are able to show that information gathered from our data-driven investigation can be used to provide recommendations for improving design of future variants. That was my elevator pitch.
Perhaps you can stop sharing your screen. And okay. Thank you, Leah. So the discussant for this paper is Vladimir Barbaric. The floor is open to all. And what, do you have any questions? And of course, Vladimir Barbaric, obviously, you may have questions as well.
Yeah, sure. First of all, I want to say that it was a really nice paper, a really nice video. I found it really interesting. It was like being recently graduated. It took me back. It took me back where I was in these kinds of situations. So, well, my first question is that, do you think that it's really possible to like make a question variants like sufficiently, as you said, sufficiently different, but while still being fair? So do you think is that really possible in like these kinds of contexts, like this pandemic situation where, yeah, everyone is on their home internet? So
yeah, so it's definitely not an easy task. I have TA'd in hearing, I guess, constructive criticism from other professors that it's very hard to create an exam with one question at a time, let alone multiple variants. So while we saw even with some of the questions that we were looking at, they were fair in terms of what our dimensions were. So those we could say were sufficiently fair, but this is just kind of a scratching the surface on what it might take in order to adjust those variants in order to make them sufficiently fair. And this might vary between what class you're teaching, what language it is, because some of the results that we saw were more Java specific, but this could be different for different courses. So yes, but it might take a while and it might depend. So it depends.
Yeah, so that's it with my second point is like, what do you think it requires more effort? Like trying to defend, like developing tools and techniques to defend against collaborative cheating, or like developing tools to detect and deter it from happening? Like you can do it, but it's not worth doing it.
In my personal opinion, I think it would be better to develop techniques to deter collaborative cheating rather than detect it, because we would rather give students a fair shot at taking the exam and not try to, well, first of all, put work on the professors on processing cheating allegations, but also it's just better to try, as we touched on before, prevent cheating from happening, because otherwise that exam's not being worth giving. So I think more effort towards that side might prevent us having to do more effort on the other side.
Yeah, sure, I would agree with that. So, well, the final thing I want to touch on is like in the paper you stated that the tests were conducted on like this controlled environment, which students like did not have access to the internet, file system and whatnot. But do you think it's representative enough? Like we have changed the situation, like in which students may be taking these electronic exams, like with not that kind of control, and they have like more degrees of freedom, like for example, internet access. So.
Right. So at least at our university right now, given the COVID situation, I know that our facility, the computer-based testing facility, has their online proctoring system, and there's also ProctorU, which I'm not all too familiar with, but what I heard from the TA perspective is they have very good monitoring system of what students are doing during the exam. So again, it kind of depends on the resources that a university has, like if they have access to this ProctorU software, or if it's just on the student's honor code, which could throw a lot into the mix and kind of make things a little bit more difficult. So again, it's kind of university dependent, but at least in our particular situation with COVID, it's still a reasonable comparison, I would say.
Yeah, sure. Because like, yeah, as you said, it's university dependent. I don't think mine has like enough resources like to do that.
Yeah.
Yeah.
I was going to say, I know it's not the representative university for all universities or even in like the US or whatever, but just for our particular situation.
Yeah, sure. It was really, really nice. If anyone else wants to jump in, like that's all for me.
Any other questions? Oh, go ahead, Axel.
Yeah, thank you. Very nice paper. Thank you. I have more a comment than a question. It shows how difficult it is to rate questions. So the change you made from select the elements less than zero, the positive elements, negative ones, and the odd ones, and that's for experienced programmers, it's a trivial change, and for the students, the modulo operator comes into the game, and that looks like magic for them. And this small change completely changes your, not completely, but almost completely changes your exercise. Since you insert a new dimension with this modular operation, you might have even thought about before. I don't know if you expected that.
Yeah, because I was going to say, even before I started doing this research, I'm pretty sure I was guilty of conflating the remainder operator with the mathematical modulus. So that was something that I would have never thought twice about. And then all of a sudden you see results come in and it's like, oh, that's something that would have never occurred to somebody other than a novice.
Bastian?
Thank you. I really appreciated your paper. It was really interesting. And I had one question that I was wondering about, may have escaped me, is how did you actually implement the question variants? So technically, how did you technically implement, make it happen?
Yeah, so I think if I understand your question correctly, so I was not the instructor who wrote the question variants. This was the professor of our CS1 course. And so this is just the general process that most of the instructors would go through when creating these questions. So the way that our online assessment platform that's used for both our homework and testings is set up is that
Which one is that?
Prairie Learn.
Okay.
So can endorse that, but yeah, maybe, but.
Well, they're all great and they all suck at the same time for different reasons, you know?
Yes. I'm part of many grievance meetings on our platform, but I mean, yeah, it works. But so the instructor would write the questions that they would want to define. So taking the linked list example is just like, I want to evaluate students' ability to traverse a linked list. So they would think of and manually write these questions. So we had 4 variants in this case of the count even on positive, negative. So all these were individually written and put into an overarching question pool. So it would be the linked list question, and then all of these would follow underneath. And then once the exam starts for a particular student, one of these is just randomly selected from the pool, and only the student sees that they're traversing a linked list question was count even. So that was their linked list question. They wouldn't see the others.
And was the order randomized, like the order of questions too randomized, or just the variant for each student randomized?
For this particular exam, the order was the same. So you started out most of the time with like multiple choice questions, and then you had like a linked list question, and then a binary search tree question, and then a sorting type question. And those were always in the same order. It was just what variant went inside that question.
Okay, thank you. Well, the reason I'm asking is we're the same instructor I just spoke of a little while ago. He's really great guy, and really industrious with his teaching, and he implemented his own custom exam compilation script for Google Docs, which is very curious because he doesn't like our campus system. I guess that's the main reason why. Thank you.
That's right. Thank you.
Elke?
How many students took part in your exam at one time?
So we were on the order of many hundreds, so between 700 up to 900 for this particular semester, depending on which exam you were looking at, because students dropped. So it was always in the upper hundreds, and lately we've been cracking 1,000 students in the class. But.
And the variants, you had just the 4 variants for the linked list example, so several hundreds per one, or you had more variants for one example?
So at least the questions that were looked at for this semester, we had 4 variants for each question that we were looking at for the particular coding questions. There were some that were just the question without any variants. But this was kind of based off of some of the best practices found in some of the prior work looking at how much randomization is needed to deter collaborative cheating. So I was more on a best practices side rather than anything deliberate.
And how could you really prevent from cheating with several hundreds in one example and the same environment, because you have a controlled environment?
Right, so that would either go to the instructor on just putting out the cheating detection, whether there's word or anonymous tip on there was collaborative cheating, or we could go to there was related work that had a methodical approach to having their detecting collaborative cheating and having their on whatever that they defined cheating as. So we could go down that road as more of a research approach, but if you're going more from a teaching approach, then it would just be kind of the best effort and the same measures that you would typically take in any other exam.
I have 2 related questions. First of all, were the students aware that the questions, there were variants of the questions? And did you detect more plagiarism in the sense that students were answering the wrong question? They were chatting amongst each other on SMS or something, and you had students answering the equal question while they had the odd question, for example.
Right. So at least the data we were looking at for this paper and my part or my role in it, I wasn't aware of any cheating allegations because that was, again, on the teaching side. I had seen a couple of things as a TA, but I wasn't looking at it from a research perspective. And I believe that they were given some sort of the disclaimer that not all questions are exactly the same, but it wasn't, we weren't explicitly telling them hey, there are 4 variants of this question. It's just more of a general disclaimer.
Yes, go ahead, Mark.
I guess maybe a related question is, are you tracking how they input things? Because you would probably notice the difference between them typing in code versus, pasting in code. And that could give you an indication of, where are they actually typing the answer themselves, or are they getting it from somewhere else?
Right, yeah. So at least the way the platform stood at that time, and I believe most instructors keep the setting, is that the paste is disabled for Prairie Learn the platform. So that would help us with that, at least. In terms of tracking what students are doing, we can kind of, we can look into the logs and see the changes between what was being submitted from the previous submission and go off that if there were any major jumps in changes potentially.
Okay.
Okay, thank you. Thank you very much. Obviously, your paper generated a lot of interest because there was much discussion. Our next paper is called Introducing
we have
DevOps.
one more question on that one.
I'm sorry.
Alicia?
Oh, go ahead.
Thank you. So my question might seem like a bit of an oddball question, but just go with me.
Can you? Those are the best questions.
Can you tell me a bit about the context of your students on campus. So are kind of two parts. One is, are they in a cohort-based program where they're all in the same classes together? And two, if not, how socially connected are they, and how many friends would you say each student has in the class?
Okay, so at least for our class, I can kind of just give some general demographics I'm aware of and see how much that answers your question. So at least for our class, it's the first the intro class. So they have like an intro to like computing, and then they kind of move into the intro to programming. So it's mostly based for computer science or CS plus whatever, or and something or other, but like computer science is kind of the baseline. But also some students choose to take it who aren't CS majors but feel that the Java object-oriented are a better fit for their work than we have a computer science for non-majors, which is mostly in Python. So some of those take it. It's a little bit difficult for me to say how many friends they would have in class because so it's a very large class, and sometimes it's split up between two sections. With COVID right now, things are a little bit different, but at least speaking on this semester. But they also have labs where they're encouraged to do group work or like collaborate with whoever else is in your lab. So presumably they would have a couple of friends in the same lab, but naturally with a class that big, you would still have some loners who would rather just work by themselves. So I would say there's a variety and dynamic.
And as well, the culture of whether there's competition. Because I mean, so I've seen various universities where the culture around cheating is so different. And a lot of it depends on to what extent the students feel they're in competition with each other versus they're collaborating with each other, and whether there's a belief around courses being belled or shifted. And so I think this is a really interesting paper, and I'd also like to see it replicated across a couple different institutions with different cheating cultures. And I think that would be interesting.
Yes, I would love to see it replicated across other places because there's a lot to learn. And again, like just one institute is just scratching the surface. I would say at least for our class, the instructor kind of tries to make it known that he has unlimited A's to give out. So hopefully minimizing that competition and trying to encourage that programming is collaborative, but not all students are going to be convinced of that, but at least there's a little bit there.
Thank you.
Thanks.
Thank you. And that was a nice call for further work. So
yes.
others can work on this. Thank you, Leah.
Thank you.
So our next paper, we have to move on. The time is advancing. Our next paper is called Introducing DevOps Techniques in a Software Construction Class. So I think this is, the previous papers were more at the undergraduate level. This paper is if I understood correctly, in a professional master's program, so at the graduate level. And this paper is from the United States, and I would say we're moving from programming in the small to programming in the large, which is nice. So we have complementary papers here. So Mark, do you want to share your screen?
Sure. Let me go ahead and let's see if this works. So can people see the slide?
Yes.
Okay, great. Yeah, I'm actually, we use WebEx and we use Teams, and so I'm not as familiar with Zoom. I guess we're all getting familiar with all of the platforms as time goes on. Okay, so yeah, this is, as mentioned, in the context of a master's program in software engineering. We have a class called software construction that really focuses on trying to get the students to scale up their programming skills or background to be more sort of programming in the large. So focusing on things like abstraction, really digging into object-oriented concepts, like when is it appropriate to use inheritance. But one thing we noticed as we were teaching this class is we have all these new sort of cloud-based techniques and new collaborative development techniques and this concept of DevOps that's becoming more important. And so we described in the paper, right, this is something we wanted to introduce into this class. Our first attempt didn't go too well, which I can talk about, but our second attempt, I think, has started well, and so we're still building on that. But the questions we're trying to answer are, right, one, how do we teach these skills to our students? Right? How do we actually create effective exercises that we can not have in its own class, but integrated into some of our other courses? For instructors, what challenges might you encounter along the way? And also for students, but especially for those of us that are trying to add these types of things in, are there existing resources that can help? If you're trying to pull this information together, do you have to do it from scratch? Is there information you can use? How good is that information? You're right, there's some challenges of integrating that into your class. And so I have the talk recorded, so hopefully people had a chance to watch that. But please just also ask me questions to find out more about what we've done here in terms of integrating in some of these concepts, of having these hands-on activities that the students can do. Some of the challenges that I guess I'll say I encountered as the person teaching this, and that you would probably encounter if you were to try to adopt similar lessons into your class. So I guess that's all for the elevator pitch.
Thank you, Mark. Maybe you can stop sharing your screen.
Yeah.
So the discussants for this paper, your paper, you have two discussants. I don't know if that means anything, but Robert Chatley and Ivan Procaccini, and you're both online.
Yep.
I hope I did not mess up your names too much. So the floor is open to all, but of course, obviously to the two discussants in particular. So go ahead.
Ivan's going to kick off, I think.
Sure.
Okay,
yeah.
Go ahead, Ivan.
So thank you very much, Mark. To begin with, I feel and I felt reading your paper and watching video that your work falls pretty much in line with what we've done and what we are going to present next. So the first question that I'm going to ask is, I'm interested in knowing the rationale behind setting these assignments in a graduate course rather than including them in an undergraduate course. So what is it that guided your choice there?
Okay, so some of it is, I guess, just the nature of the types of courses I teach. I mainly teach courses in our graduate software engineering curriculum. And so for me, when I was looking to add these materials in, that was a logical place to start. I don't tend to teach especially the intro courses on the undergrad side. So I'd like to work with the instructors teaching those to see if we can start integrating more of those concepts in. But for me, I guess this was the thing I was already doing. So it made sense to start looking into that as, can I integrate these concepts into courses that I'm already teaching myself?
Where do you think it would fit if you had a free hand to put it wherever you liked in the curriculum? Where would you put it?
Okay, yeah, that's a good question, and that's something where I really liked your paper that's coming up next. These sort of concepts in there, I don't think I'd put it in one place. I think I would distribute it. So right now, for instance, our undergrads don't tend to encounter version control until they get into the software engineering classes, which tend to be their junior year. And I would move that back to their first classes. And then I would start slowly integrating in these concepts, things like continuous integration. I think it makes a lot of sense where if faculty are providing some sample test cases, and then just every time you commit, right, it just runs those tests and you can get a better idea of how your code is doing. So you can start working these things in. And I was really actually encouraged looking at your paper that they just start adopting these techniques, right? They obviously find them useful then because they're using them without being told to use them. And so just starting at the beginning, adding these in, and then I would love it when because I also teach our undergrad software engineering class quite often. I would love it if when they got to that class, I don't need to explain Git, right? Which right now we have all these lessons on Git and I go through and they do exercises. It'd be great if they just came in and they knew how to use it and they already saw the value of using it. So that's ideally what I do. But I guess in our graduate program, we do have a lot of students coming in that are switching careers. And so it makes sense for them. They don't necessarily have an undergrad degree in computer science. They usually have it, I mean, some of them do, but some of them have it in a different area, and they've just kind of moved into the software engineering profession because that's where the jobs are, and that's where they develop an interest in it, and then they want to come get a degree in software engineering. And so for them, it's still valuable to have those in our graduate program, and again, sort of sprinkling it throughout, because then they would get to see that material themselves, which they wouldn't have seen in an undergrad program.
Is there anyone else that wants to ask a question? Otherwise, we have a few more to go through.
But I'll tease you to begin with, Ivan. I will tease you. Next time you come to a software engineering conference, make sure you wear a shirt that says software engineer, not computer engineer.
This is a gift. That's, yeah. So I would never do that. In fact, you're right. Software engineer is much more suitable.
Go ahead, Ivan. We have a question from Ben Reed here. Go ahead, Ben.
Yes, thank you. I know this is a little perhaps off the wall, but one of the things that jumped out in your presentation was your comment about the documentation.
Yeah.
I remember when I came from industry, I tried to teach a class using blogs that I had used in industry to understand concepts, and it didn't fly. Like, for exactly the reasons you say, like people, like it's not structured well for an academic environment. The thing I was wondering was, if you are teaching for DevOps, that's a skill you need to know. So I like, and I've seen it in industry where students come in and they can't work with bad documentation. And it really appears to me, even though it shouldn't be this way, but as industry trends more towards DevOps, the documentation gets worse. So I'm wondering, where are our students going to learn how to deal with bad documentation? Or should we just leave that for, yeah, when you get out there, you're going to have to grow?
Yeah, that's a good question. I think some of it is, and this is just my view, I've done no research on this or anything like that, but as they get more used to dealing with documentation, even with bad documentation, they will be able to figure it out better. I think the problem that I'm seeing with ours is they're not that used to having to turn to this type of documentation. And so they just don't have a good sense of, is it good? Is it bad? The types of problems they were running into looking at it were just problems of being able to generalize, right? I see this command, and do I just, what does that command depend on? What parts above on the same page would I have had to do for this command to work? And what parts would change for me based on the thing I'm doing versus what parts always should be here because that just is needed for the command? And so some of that's just experience. It's just, I don't know a way around that. I think they just get used to that and they start being able to generalize that and to pick out pieces. And if they realize it's bad or something's not working, right, there's obviously a point at which, yeah, the documentation could be wrong, but they don't have enough context to know if it's not working, is it their fault, or is it they really do need to go look someplace else? And so, yeah, I don't know a good way around that other than just to expose them to that and to give a lot of structure early on to say, here's the documentation, here's my explanation of the documentation, and I can point out the pieces in here that, this is what you need, and these parts change, and these parts have these dependencies. And there might be a way to model that in some way that would actually help them, but I'm not sure of that. But I just think they need a lot of initial handholding.
In your course, like towards the end, did you see them able to deal with bad documentation better, or?
No, but I think it's probably because the documentation got, I don't want to say worse, but definitely more involved. Because at first we're talking about things that are fairly self-contained, right? It's like, okay, we're using Travis, enable Travis, and there's some options in the configuration file, but it's not that hard. At the end, you're talking about Kubernetes, and there's huge amounts of documentation, and there's books, and there's parts that if you just don't know what's going on, it's just puzzling. Yeah. And so there's a lot more documentation there. I guess maybe a good check would be next semester, a year from then, if we went back and revisited it, how would they process that? I think that'd be interesting to look at, but I haven't done that. But maybe that would give us a better idea of how they're able to process that later.
Ivan.
So I'd be interested in knowing how you handled the marking part. So what bits did you focus on when you were marking? And also, did you mark it all by yourself, or did you have a team of TAs or helpers to help you with the marking?
Okay. Marking actually in this case was fairly easy because I mainly looked, because what I was doing was I was introducing this in the context of the existing material in the class, but it wasn't directly linked to the existing materials. They didn't need to use this for their existing homework exercises where they're looking at inheritance and concurrency and things like that. So what I mainly was looking for there is, did they make basically a good faith effort to do it? I didn't want them to get frustrated that this is an important part of their grade and they're learning this new material. And so I would imagine that if you had a course more focused on this, then that becomes more of an issue. But in this case, what I required them to do was, for the Docker assignment, they had to actually put out a Docker container that an image that I could then get off Docker Hub. And if they could do that, right, and it was a small enough class, it was around 15 students, that if they got stuck on something, I could work with them. But my main goal was for them to get through it. And so I wasn't so much worried about specific things working or not working. It was really graded on, did they try their best to do it? So yeah, it's easier than trying to assign actual grades to it. I do admit that.
And I wondered if I could ask a kind of practical question. I think you were using a lot of Google Cloud functionality. Yeah. So what's the sort of process for getting people set up with that? Do you have to make them special accounts? Do they need credits? How did you manage that kind of stuff?
Yeah, actually Google makes it really nice for this because you can apply for credits and they just have an online form where you give information about the class. And what they'll do then is they will just send out information to you as the faculty member with, like, you can get credits for yourself and for any TAs, and then you can get credits for your students. And the process for the students is there's just a link all the students can use. And when they click the link, they need to fill in an email address, and that email address has to be in one of the domains that you provided. So what I'll tell them to do is to give they have a @students.ecu.edu address. So they use that to request the credit. It then sends them a link that they get a billing credit for when they click the link, and it just applies that credit into whatever Google account they're signed in with. So they don't need to create a new one just for the university. I know there's some differences. If you're a Google university, we're not, right? We don't use Google Drive and Google Docs and such as part of our internal support. It's a little different in that case, but in our case, that's really all they have to do. And then they get a $50 credit, and they can use any of the stuff that's up on Google Cloud, any of the services up there. And then if they run out, you can request more credits for them. So it's nice because they also don't need to give a credit card, for instance. So they don't need to run the risk of semester's over, they go away, they forget to shut everything off, they get a $500 bill later because they had something running that took a lot of processing power. And there's very few restrictions. You can't mine cryptocurrency, but beyond that and a couple of other things, you can pretty much use everything.
Oh, sounds good.
Very quick question, Vladimir, and then we'll move on to the final paper.
Yeah, sure. So do you find that you had any limitations with this kind of tier access in Google? Because, well, for example, I have an access, like kind of same access for AWS with their educational program. But when I try to deploy some things or may kind of a trigger, not so difficult stuff, that they had like these kinds of restrictions put in place so you couldn't do it. It was really difficult to do. So yeah, do you find that that's the same with Google, or they are more flexible in that kind of stuff?
My understanding is that, I know that AWS has some limitations on educational credits. I don't think Google does. I think the limitations they have are the same for everyone. So again, no mining cryptocurrency. It's just something in general you're not supposed to do in their cloud services. I say the big thing for the students is just to remind them that they may overestimate their needs and go through a lot of credits very quickly. So sometimes they'll want to spin up a very powerful Windows server, for instance, that uses up all their credits in 2 weeks. They don't need 32 gig of RAM and a huge drive and all these processors and such to run a website.
Yeah, sure. Thanks a lot.
Sure.
Thank you. Obviously, lots of questions. So all of these papers have generated much interest, including the one that was just presented. So our final paper for this session, I think, is to make a segue from the previous papers. The 4 previous papers talked about changes and modifications and improvements to a particular course. Now this paper talks more at the program level, at the entire program level. I thought that was interesting. And we're also talking about DevOps. The paper is from the United Kingdom. And the paper is titled Threading DevOps Practices Through a University Software Engineering Program. So to conclude about talking the program about it at the higher level rather than at the course level, I think is a nice way to have a nice final paper. I don't know which of you will be presenting. You're both online. That's fine. That's excellent. So Ivan, would you like to share your teaser slide? Go ahead, Ivan.
Yeah, sorry, I had lost my my Zoom window. Okay, so pretty much like following up from what Mark has just presented, me and Dr. Chatley here today, we want to basically discuss with you our recent attempt to include the teaching of DevOps practices in our degree. So there are basically 4 main distinctive aspects of the attempt that we made that we can summarize as follows. The teaching takes the form of a 1-week-long assessed laboratory group exercise for second-year undergraduates. And it's a staged exercise that starts from a very simple but functional Java web application that we get the students to set up a build pipeline for, and then they deploy the app first to the internal departmental network, then to a platform as a service provider, Heroku in our case, as a standalone app first, and then still to Heroku, but as a containerized app using Docker. Each of these steps is motivated in the spec by limitations with the previous deployment solution with respect to some requirements that we change or add. We also introduced we introduced early and prompt the students to develop some skills which we require more or less explicitly to be put into practice in all subsequent programming assignments that they have during the course of their degree. This makes this lab exercise just the start of a continuous experience rather than just a self-contained and isolated one. We also provide pointers in the spec to official documentation for the configuration of tools and command line sysadmin tasks on their virtual machines, so as to further consolidate the skills that they have less formally acquired up to this point along their academic path. Since we introduced this exercise, and this was 2 years ago now, we have collected positive results in 2 aspects, basically, in the solidity of the DevOps infrastructure that the students are able to put in place for their more mature group projects in year 2 and 3, as well as in the confidence that they show that they have reported with these practices in an industrial context, even if they are presented with a new tech stack. And this is in the context of their industrial placement that they undertake between their 3rd and 4th year. This is the end. So I'm both of us are open to questions, and I will stop sharing.
Thank you, Ivan. So the discussant for this paper is our previous author who talked also about DevOps, obviously, so Mark Hill. So the floor is open to questions for all, but in particular, Mark Hill. So I will take the liberty of speaking French for 1 second here. Vincent, tu peux poser ta question. Le plancher est à toi.
Merci, thank you. I was not able to figure out at what level you're doing this course. In the bachelor or at the master level, or?
Yes, undergraduate level. So this is bachelor year. So we have basically two programs. One is a 3-year BEng and one is a 4-year MEng, but they are all pretty much, well, they are completely overlapping in the first 2 years. So
okay, and in that bachelor level or mixed, at what year are you taught a second year?
Year 2, yes.
And your first year is general or is focused on computing, or they have some generals?
It's focused on computing for the first year, so computing and mathematics, but no general engineering.
Okay, thank you.
Yeah, so they would already have some fundamentals of programming, also basic use of Linux, Git, as Mark mentioned earlier. Those things are covered in first year, and this is when we start to go into slightly larger projects in the second year.
And I was also wondering how you can have the 20-minute assessment, because there is a lot of questions that you have described, and does it fit in 20 minutes really?
So we have so yes, if you please, I have ready the assessment sheet because I thought it could be helpful to basically visualize how we are.
Please share it, Ivan.
Yes.
Share your screen.
Yes. Give me 1 second. There we go. Yeah. So you should be able to see it. Yeah. Can you?
Yes, we do. Yes, we do.
Okay, so yes, basically we go through these questions with them in the course of 20 minutes. Bear in mind that time-wise, we have tried to divide. We have tried to group students together so as to form a reasonable number of groups, and we also have the strength of a little team of assessors. In that case, so it's not just me and Robert. We are, I think last year we were 5 or 6. So 6 for, can't remember exactly how many groups we had, probably something like 20, 22, 25, something like that.
Probably more than that, I would think.
A bit more, okay. But yes, we managed to do that over the course of 3 lab sessions, each lasting 2 hours.
So that each group gets 20 minutes with an assessor, and they go through these questions and tick the boxes and ask the students to demonstrate things, ask them their understanding of things in a quick way. So it's not a heavy assessment, but it's just to check, have they done all the things that they need to do? Yes,
and it's quite structured as well. So there is a little time at the end for them to discuss what feedback or any other observations that they might have, comments, but most of the 20 minutes is dedicated to going through these points and checking whether they achieved the objectives that we set for them.
Does that answer your question, Vincent?
Yes.
Perhaps you can. Yes, you can stop sharing your screen, Ivan, please. Thank you. Any other questions?
We have a few ready. Yeah, sure. So I guess one question to ask, and just because we talked about this a bit earlier, have you seen, because you're having the students also look at this documentation that's online from the vendors, I'm just curious if you've seen similar, in essence, sort of abstraction problems that they have where they're not really clear how to interpret the documentation or what parts apply to them and what parts they need to change and what parts stay the same, that kind of thing.
So we did see that to some extent. I have to be honest, the biggest problem we found with documentation early on in the week that they have for completing this exercise was that many students tend to arbitrarily skip certain preparation steps when they read the documentation. So they skip and they go through the documentation and they start actually executing stuff from the command line halfway through the documentation page, which means that something doesn't work. So they raise their hands, and many times we find out that you just skipped the first 2 steps. So it's expected not to work because you're not doing some preparation work. But yes, I think that's pretty much what we found. And we did spend some time going through that documentation, or the documentation that we indicate in the spec ourselves, so that we were as sure as possible that it made sense without too many difficulties.
Okay. Later on, as they continue to use this, what types of variation do you see in later classes? Do they mainly stick to the same technology stack that they were introduced to at the beginning? Do they start branching out and trying new things? You did mention that they're comfortable with this when they say they go and do an internship. They might use different technologies. But in the courses that you have in your program, do they just tend to stay with what they saw first?
I think there's an interesting range. So there are some people who obviously are comfortable with the set that they've used, and so they go for that. And we've even seen them applying that when it wouldn't be the best choice, but they were like, well, this is what we did before, so we've done this again, even though it's perhaps not the best fit, which was interesting. But then we also see groups who are branching out into doing things on AWS or things on Azure or GCP, and they're able to make that mapping of, oh, okay, previously we had our code in GitLab, and now we're going to put it in AWS, code deploy or something, and they can make that mapping between the function of the components. So I think it depends, yes, kind of on the ambition of the groups. Some people make that mapping very easily, and some people want to stay with the stuff that they've done before. But we tend to leave it, especially in projects, leave it pretty free for people to choose what they want.
Okay. Looks like there's a
Mark,
question.
Is there anybody else? Otherwise, we'll go ahead, Mark. Go ahead.
Okay. I had, I guess, one more thing, but I wasn't sure if someone else had a question. Thought I saw a hand come up, but maybe not. Have you seen a need for later reinforcement of specific things? So maybe part of it sticks really well, and part of it they need to go back and they need to review, or you need to integrate things into later courses just as a refresher. I'm just curious.
Interesting. I mean, we haven't, but I wonder whether I think probably what we're not doing is observing closely what they do in later courses to see how closely they're following the practice we might want. So we can see that they're using, Jenkins and something in a later project course, but we don't work closely enough with the groups to see, like, oh, how small are your commits and how frequent are your builds, and are you going red, green, and all this stuff. That would be interesting to be able to work more closely, kind of coaching the teams a little bit more. And so obviously one of the difficulties is the variation, whether you then say, oh, well, we have this problem where we're trying to deploy Docker containers to GCR or something. Like, okay, I haven't used that, and you have, so you're the experts rather than us. So it's difficult to map it onto all the various range of technology. But I think what probably is the fundamental thing that we try to get people to do is, smaller changes, smaller pull request if you're going to do a small request, more frequent builds, try and do that in a smaller iteration, try and release more often. So it's more pushing of the forces that you would be coaching people in an agile project delivery rather than specific technical practice, I think.
Okay.
We're kind of okay with the technology, but they're just, maybe it's a different dimension that I feel we need to push them on to be more lean.
Okay.
I do believe there was a question from Vladimir.
Yeah, I
Go
wanted
ahead,
to ask,
Vladimir. I missed you. Sorry. Go ahead.
No problem. So I wanted to ask if you found like any issues like configuring like their local development machines, because, well, for example, right now, if I want to develop on my local machine, I have a Windows machine. So if I want to run a Docker container, that's kind of really, really messy. So do you encounter any problems with your students, your group of students, or?
So in the attempt to normalize this situation, these differences, we we prompt them to use the provisions from the department. So we do have a cloud of VMs that they can use for deployment, but also as a base for running their pipeline in some sense, right? So that means that they can basically, they just have to know the Linux environment, strictly speaking. These doesn't mean that they can get their hands dirty and trying to run Docker from Windows or anything as such, because we also give them the pointers to the documentation, which is pretty clear in terms of setting up in different environments.
Oh, okay, that's really nice to know. Yeah, I was wondering because usually configuring environments like in different machines when, for example, in my university, everyone didn't trust the department computer, so everyone bring their laptops, and usually they don't have the tools installed correctly or whatnot, and that generates lots of trouble. So
I think we will definitely see that more this year when people are working particularly remotely and they're using their own computers, where if they were in the building where you have all the lab computers that people come and use, they're all identical. But this year people are using Windows, people are using Linux, people are using Mac, people are using some special variant that they prefer, and then they come and say, oh, it doesn't work, and you have to analyze, well, okay, you're running on Windows, and okay, you have this, and then you have this, which definitely adds a layer of complexity for supporting the course, I think.
Yeah, sure, thanks.
Any final question? Okay, so first of all, I'd like to thank all our speakers who presented, had submitted papers, and I listened diligently to all the videos. I thought they were all 5 of them very well made. I thought this flipped classroom way of doing things generated a lot of interest. I've been tracking, we've been 25 to 35, 33 people throughout the session. So obviously this generated interest. People are not logging off. That's good. And there's not only the 5 speakers in the room, there's a bunch of other people as well. So I thought that was very worthwhile. And Bastien, I don't know, this is the end of the, tell us perhaps what's going on in the rest of the day.
Right, so for those of you on the east coast of the United States, you now have an hour of lunch break, roughly. For those of you who are in Europe or further east, you now have time for an hour for dinner. And either way, we're looking forward to seeing you here again for the afternoon session, which I'll remind you is the tutorial called A Gamification Toolset for Improving Engagement of Students in Software Engineering Courses. So please join us for the tutorial. It will be fun. I'm sure there'll be an activity and we can do awesome things. And until then, enjoy your food.
Thank you all.
Also, a reminder, there's the networking session. If you're bored by yourself, go join us in the networking rooms.
Thank you.
Thank you. Bye.
Everyone.
Bye.
Thanks a lot. Bye.
Thank you. Bye.
Bye.
Mark, if you're still here, you can discontinue the recording for me or assign me as a host and I can do it for you.
Yeah, I'm trying to figure out how to do that.
You can right click on my face and say make host.
Okay, I was kind of surprised to find out that it was me at the end when I went to leave, and it let me see, there you go.
Look at that. Thank you very much. I think Zoom just naturally assumes the person with the highest apparent authority at a given moment. So you look trustworthy. It's you.
I guess some algorithm might, yeah. I parted my hair on the right side today or something, and so it assumes that I'm trusted with that kind of authority. So
well, maybe. I'm gonna end this stream here.